Hi, this is Sue Burke. Welcome to my podcast. Why are rare earth metals important? If you like tech, television, podcasts such as this one, Spotify, drugs, meaning pharmaceuticals, your cell phone, alternative energy, greener manufacturing methods, EVs, you name it, then rare earth metals are important to you. What are rare earth metals anyway? And if they're so rare, what are common uses for rare earth metals? And why should we care about rare earth metals when we're worried about a recession? Let's take a step back and look at what rare earth metals are. Rare earth elements, or rare earth metals, are terms for 17 of the over 118 elements on the periodic table. Here's a fun fact: rare earth elements aren't really rare. Rare earth elements, or metals, are found in abundance across our planet. Rare earths are more expensive to mine than most metals because rare earth metals tend to occur together and are difficult to separate from one another. So, the term rare earth elements, or rare earth metals, is somewhat misleading. For the record, I'm going to give you the definition. Rare earth elements, or rare earth metals, are any group of chemically similar metallic elements comprising the lanthanide series, scandium and yttrium. I do have a graph on my website so you can see where they are in the periodic table if you're interested. Okay, so now we know what rare earth metals are, and that I interchange the terms rare earth metals and rare earth elements with reckless abandon. So what is the big deal? Why are they important? Rare earth metals are important because of their applications. Rare earth elements are essential for many high-tech products such as smartphones. For the record, 97% of Americans own a smartphone. I'll give you a few quick examples. Terbium gives our LCDs their green color. Terbium is also used in low-energy light bulbs and solid-state drives. The red color on your screens is from europium oxide, a europium compound, and it's widely used as a red phosphor. We wouldn't have Elmo without europium, at least not on our screens. Indium tin oxide is what makes your screen work as a touch screen. Smartphones also use neodymium, dysprosium, lanthanum, and praseodymium. Oh my gosh, I'm aborting the names. I apologize about my pronunciations. But to think that Romans once thought of salt as white gold. Salt is a lot easier to pronounce. A magnetic resonance imaging system, MRI, is medical imaging diagnostic equipment. MRIs can be used to obtain images of any section of the human body. MRIs are extremely sensitive to soft tissue lesions, so they are effective for the diagnosis of cancer, tumors, cerebrovascular and nervous system diseases. We can thank gadolinium, which has paramagnetic properties, and that means when gadolinium moves through a magnetic field, such as an MRI, its temperature increases, which makes it useful to enhance image quality in MRI scans. More common uses for rare earth metals are manufacturing of specialized optical glasses, such as infrared absorbing glass, as well as camera and telescope lenses. Lanthanum can also be used to make steel more malleable. Neodymium magnets are widely used in radar technology, satellite communications, remote telemetry, electronic tracking, and electronic countermeasures. If you want to read more about space junk, satellites, go to my website. Neodymium, dysprosium, and praseodymium are all needed for motors in electric cars and necessary for wind turbine production. Rare earth elements aren't just used for tech. They're needed for pollution abatement, power generation, water treatment, and even drug therapies. Samarium is used in the drug Quadramet, which relieves bone pain in patients with osteoblastic skeletal metastases. Rare earth elements are used in the production of clean energy tech, as I said, to include advanced auto propulsion batteries, fuel cells, and electric motors. I only graze the surface of some common uses for rare earth metals or elements, whichever term you prefer. Rare earth metals direct our economy the way Stone Age flint was valuable during the Neolithic era, or the way Aztecs once considered cocoa beans more valuable than gold. I still consider myself in the Aztec camp. But rare earth metals have nothing to do with chocolate, so let's move on. With all this importance of rare earth metals, coupled with the fact that rare earth metals are difficult and expensive to mine, will the world run out of rare earth metals? Where do we mine our rare earth metals anyway? And what about the horrible term we've all come to know, supply chain? The United States has designated rare earth metals as critical materials. Critical materials are key components of products that are essential to the economic or national security of the United States and are susceptible to supply chain disruption. I have a copy of this report on my website if you'd like to see it. Unfortunately, in 2020, the United States imported 100% of its supply of the 17 rare earth elements. This was provided by the U.S. Geological Survey. Yes, you heard that correctly, 100%. The biggest supplier of rare earth metals is China. China produces 85% of the world's rare earth metals. China also has a history of restricting trade for political reasons. The United States has fallen way behind in rare earth metal production. President Biden's goal is for half of all new cars sold by 2030 to be electric. But given the shortage of rare earth elements, that's like asking Top Chef contestants to make a main dish with 2 tennis balls and a peanut. The demand for these critical materials is set to skyrocket by 400 to 600% over the next several decades. For materials used in electric vehicle batteries, demand will increase even more, as much as 4,000%. So, what are we doing about the supply chain issues with rare earth elements? What am I doing about my pronunciation of rare earth elements? Well, I'll keep trying. Now, considering that 40% of the world's rare earth element reserves are located within the borders of the United States and its ally nations, yet China remains the #1 producer, we do need to do something. Dr. Lawrence Menard, Deputy Associate Director for Energy and Minerals at the U.S. Geological Survey, said that supply chain disruption is likely to be a more immediate consideration than supply exhaustion. President Biden has left executive orders from the last administration in place. I have a link on my website. The order asked several organizations within the government to assess the supply chain risks and ask for solutions. Our president further issued EO 14017 on February 24, 2021 to discuss supply chain risks. Okay, we have executive orders, but what are we going to do about our dependence on rare earth element imports? Our dependence on cell phones? Well, I'm guilty of that, and I don't think I'm going to do anything about it. So, what are the challenges of extracting our own rare earth metals and reducing our dependence on imports? Roasting is a common process used to extract rare earth elements. Roasting is energy intensive and requires exposure to concentrated acids. Companies that dig for other resources might start extracting rare earth elements from deposits of different materials. We could someday obtain these elements as byproducts from power plant coal ash and coal mining waste. Rare earth elements can be found in concentrations higher than other metals, even gold and silver, but remember, the dispersed locations of rare earth elements make them uneconomical to mine and extract. Plus, these elements chemically bond to each other and to nonmetal elements. This makes extraction and separation of rare earth elements expensive, difficult, and fraught with environmental risks. Rare earth elements seems to be easier to say than rare earth metals. Not sure why. So, what do we do about the supply chain issues and what solutions can we come up with to extract our rare earth metals by ourselves and do it economically and without hurting our environment. Science will come to the rescue, of course. Let's start with acid mine drainage. Acid mine drainage is the acidic water that forms when surface water, such as rainwater, snowmelt, or pond water, and air are exposed to iron sulfide. Iron sulfide is a solid waste product of coal mining. And what does awful acid mine drainage have to do with extracting rare earth elements? Well, in 2020, scientists from Penn State developed a two-stage treatment process that allowed them to recover higher concentrations of rare earth elements from acid mine drainage. How cool is that? Use gross pollutants to extract what we need. How about a protein-based sensor to thwart supply chain issues so we won't run out of rare earth metals? Penn State researchers, go Penn State, developed a new protein-based sensor that changes its fluorescence when it binds to rare earth elements. The protein sensor will facilitate mining and recycling of these elements. Lanmodium is a fluorescent protein that they used because it binds to lanthides. Remember that lanthides are 15 of the 17 rare earth elements. I have a chart on my website to look at it if you're a more visual learner. Anyway, this protein opens the door to inexpensive methods for selecting sensing of individual lanthides in the environment. How about ion exchange? A chemical process called ion exchange could extract rare earth elements in a safer manner than other extraction methods. Ion exchange is a reversible chemical reaction wherein an ion, which is an atom or molecule that has lost or gained electrons and thus acquired an electrical charge. An ion from a wastewater solution is exchanged for a similarly charged ion attached to an immobile solid particle. Remember how rare earth elements are bonded to other elements? Essentially, that means rare earth elements are sticking to the surface of the molecules found in coal. And researchers used a special solution to pluck the rare earth elements out. I have an article link on my website that talks about the rare earth elements and ion exchange. The solvent is both inexpensive and environmentally friendly. How about using salmon semen? Yes, you heard that correctly. Salmon semen. It appears that salmon semen has a sufficiently high affinity to absorb rare earth elements. Don't ask me how the researchers came up with this, but I do have this study on my website. That's www.susanburkecook.com. Anyway, this method is more effective with the larger rare earth elements, such as dysprosium and lutetium. And I'm about done with salmon semen. Maybe Rice University researchers have a viable solution too. They applied a flash joule heating process to coal fly ash and other toxic waste. It had to get pretty hot though, 3,000 degrees centigrade, which is 5,432 degrees Fahrenheit in 1 second. But at least they didn't use the caustic acids. They more safely extracted rare earth elements essential to our modern electronics and green technologies. I have a link for their study on my website too. We rely on rare earth elements to produce many necessary items, including computers, smartphones, rechargeable batteries, electronic vehicles, magnets, and chemical catalysts, not to mention medications, green technologies, and manufacturing equipment. And this demand will only grow. It's time to build our own resilient supply chains because rare earth metals are important to every aspect of our lives. And I do have the 250-page report that the previous administration and President Biden requested. It maps the supply chain issues for not only rare earth metals, but for pharmaceuticals and other key items that we need. Kudos to all the amazing researchers trying to devise ways to negate our rare earth metal supply chain issues and do so using environmentally friendly methods. Professionals with knowledge of the rare earth element industry are in critically short supply. Tell your kids, nieces, nephews, or grandkids to check into environmental science as a career. I admit that I would not want to live without my smartphone. And now that my kids bought me an Apple Watch, I'm even more tied to tech and closing those activity rings, colored with rare earth metals. Plus, how could I slur all my R's, research, write these amazing blog posts, and tape these podcasts without rare earth metals? As an aside, if you have an Apple Watch and want to share your workouts with me, I'm game. I have 2 exercise friends, and I'm hoping for more. I am a sucker for peer pressure. So, do you think you'd want to live without tech? Thanks so much for listening to my podcast. And again, stop by my website, www.susanburkecook.com, and subscribe. Take care.